Hey there, Seahawks, it's Miss Adams, and in this video, we're going to take a look at the least squares regression line equation, or LSRL. Alright, so a regression line, also called a line of best fit, or the least squares regression line, is the line for which the sum of the squares of the residuals is a minimum. Okay, so that's the formal definition, and we'll look at what residuals are in the next video. Alright, so we're going to use our calculator to actually calculate the least squares regression line equation instead of like the method you may have used in Algebra 1 where you just kind of found 2 points that kind of went through most of the data and then you drew a line and you calculated the slope and you predicted the y-intercept. So this is going to be a bit more precise, but your calculator is going to do most of the work for you. So our first example, we have the number of wins and the earned run average, which is the mean number of earned runs allowed per 9 innings pitched for 8 professional baseball pitchers in 2012 regular season is given below. All right, so we have X is our wins and Y is our earned run average, and we have our data. So we're going to use the graphing calculator to find the equation of the least squares regression line. Okay, and we can abbreviate that LSRL, least squares regression line, which is the equation for your line of best fit. All right, so you're going to go to Stat, Edit. You're going to enter your data into List 1 and List 2. Most of you are pretty comfortable with that. So in List 1, you'd have 20, 18, 17, 16, 14, 12, 11, and 9. In List 2, you'd have 2.73, 3.29, 2.64, and so on. All right, and so once you have the data in your list, you're going to go to Stat. You're going to go over to Calc, and you're going to do a linear regression. Now for statistics, we use the, there's 2 versions. We use the A plus BX option, which is stat, calc, and then the number 8. And then it's going to pop up with a little options, and it's going to say your X list. You're going to put that in as list 1. Your Y list is going to be list 2. For most of you, that's how it'll already be set up, and you just go down to calculate. And then you're going to get this equation that says y equals a plus bx. You have a, you have b, you have r squared, and you have r. Some of you may not have r squared and r. That's just because your diagnostic is not turned on. And you can turn that on if you want to by going to second 0, which is the catalog feature, and scrolling until you find diagnostic on and hitting enter twice. But really all we need is a and b, and we're going to plug it in. So it says y equals a plus bx, so I'm going to plug that in. So y, and it's y hat. The hat just means those are predictions of my y value. So y hat equals a, which is 6.49, plus b. Well, b was a negative, so I'm going to put minus 0.19, which was, my b was negative 0.19, times x. Okay, now what I would really prefer is to have this in context, which means I know that y stands for the earned run average and x stands for wins. So I would plug in earned run average with the hat. So my predicted earned run average is equal to 6.49 minus 0.19 times the number of wins. All right, so now I'm going to use the equation to predict the earned run average for 5 wins and 15 wins. So I would take my equation and I would plug 5 in for x. So I do negative 0.19 times 5 and add 6.49 to it, and I get 5.54. So for 5 wins, we would predict the earned run average to be 5.54 runs. And then for 15, I would plug 15 in for x. I do negative 0.19 times 15, add 6.49 to it. I get 3.64. So for 15 wins, I would predict the earned run average to be 3.64 runs. All right, so now interpret the slope and interpret the y-intercept. Well, my slope was the negative 0.19. Okay, so for every 1 increase in the number of wins, the earned run average decreases by about 0.19 runs on average. Okay, so there was a negative relationship because the slope was negative. So it was decreasing. So as the number of wins increased, the number of earned runs average decreased. Okay. So you want to have in there that on average, because remember when you're calculating slope, it is an average rate of change. And you want to have about, because it wasn't exactly that amount, we kind of rounded it. We're also making predictions. All right, so you want to have some of that vague terminology in there. All right, interpret the y-intercept. Well, the y-intercept would be when x is 0. So that would mean my number of wins is 0. Okay, so, and that was 6.49. So if the team had 0 wins, we would predict the earned run average to be about 6.49 runs. All right, so now use the data below to find the least squares regression line equation. So I'd really like for you to pause this, put it in your calculator, stat calc 8, get the equation, and then use the equation to predict the height of someone with a shoe size of 8. All right, so hopefully you paused it, you tried it, and then here's what you would get. So height, the predicted height, is equal to my A value was 51.36, plus my B value was 1.87, times my X variable, which is shoe size. Okay, so the 51.36, that is my y-intercept, and the 1.87, that is my slope. Okay, remember your slope value is always going to be attached to your X variable. All right, and so then when I figure it out for somebody who has a shoe size of 8, I plug 8 in for X, and I calculate it, I get 66.32 inches, because it was height in inches. All right, I am going to show you how to do this in the calculator in case you are struggling. All right, so this is how you would do that second problem in your calculator. So you're going to go to Stat, Edit, and you're going to enter your data into List 1 and List 2. I already have it here just to save time. And then I'm going to go to Stat. I'm going to go over to Calc, and then I'm going to go down to Option 8, or I can just press 8. And then my X list is List 1, my Y list is List 2. If it says something else and you need to change it, if I want to change this to List 2, I just hit Second 2. And then I'm going to go down to Calculate and hit Enter. And this is going to give me all the pieces that I need to plug into my equation. So A is my y-intercept, B is my slope. I plug those values into this equation. Don't forget your hat on the y. And that's how you calculate your equation. All right, go Seahawks.